In this video, we'll understand model distillation in a simple and practical way. We'll start by comparing it with RAG, then break down the teacher-student idea, soft targets, temperature scaling, and finally look at the real business value. Let's get into it step by step. Modern AI models can be very powerful, but they are often heavy, expensive, and slow to run in real-world environments. That is where model distillation becomes important. It helps us keep much of the intelligence of a large model while making deployment more practical. Model distillation, also called knowledge distillation, is the process of transferring knowledge from a large model called the teacher to a smaller model called the student. The goal is simple: get a lighter model that still performs well enough for practical use. In distillation, the teacher model is usually accurate and powerful, but costly to run. The student model is designed to be smaller and faster. Instead of learning only from labeled data, the student also learns from the teacher's behavior, which gives richer guidance. Now let us look at this in a simple table format. REH vs model distillation. Two advanced AI methods with very different goals. Before going deeper, let's separate model distillation from RAG. RAG improves answers by retrieving relevant information and then generating a response. Model distillation does something else entirely. It compresses knowledge from a large model into a smaller one, mainly to improve speed, efficiency, and deployability. A key idea in distillation is the use of soft targets. These come from the teacher model's output probabilities or logics. Unlike hard labels, which only say what the final answer is, soft targets reveal how confident the teacher is across different classes. That extra information helps the student learn patterns more effectively. Now that we've covered core concepts, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What is the main goal of model distillation? The correct answer is create a smaller efficient model. Model distillation focuses on transferring knowledge from a large teacher model to a smaller student model for efficient deployment. Question 2. In model distillation, the larger model is called the The correct answer is teacher. The large, more capable model is called the teacher, and the smaller model learning from it is called the student. Question 3. Which statement best describes RAG? The correct answer is it retrieves context before generation. RAG combines retrieval with generation to produce more contextually grounded and factually informed responses. The first step is to build or use a strong teacher model. This model is typically trained on a comprehensive dataset and achieves high predictive performance. The issue is that such a model may be too large or too slow for many production environments. Next, we collect the teacher's outputs. These can be logics or softened probabilities. They contain useful relationships between classes. For example, the teacher may say one class is most likely, but another class is also somewhat similar. That nuance is valuable for the student. Now, the student model is trained to imitate the teacher's output distribution, not just the final answer. A common approach is to use a loss such as Kullback-Leibler divergence, which measures how different the student's predicted distribution is from the teacher's distribution. Temperature scaling is often used during distillation to soften the teacher's output probabilities. Instead of one class appearing too dominant, the distribution becomes smoother. This makes it easier for the student to learn subtle similarities among classes, which is one of the biggest advantages of distillation. Now that we've covered how it works, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. What do soft targets mainly provide to the student model? The correct answer is confidence across classes. Soft targets show the teacher's confidence distribution across classes, giving richer learning information than hard labels. Question 2. Why is temperature scaling used in distillation? The correct answer is to soften output probabilities. Temperature scaling makes probability outputs more uniform, helping the student learn more nuanced relationships. Question 3. Which loss is commonly mentioned for comparing probability distributions in distillation? The correct answer is Kullback-Leibler divergence. KL divergence is commonly used to measure how the student's output distribution differs from the teacher's. The biggest benefits of model distillation show up during deployment. Distilled models use less compute, consume less power, and respond faster. That makes them highly suitable for production systems where cost, latency, and scale matter a lot. Model distillation is especially useful in mobile and edge computing where hardware resources are limited. It also fits real-time systems like autonomous or interactive applications where speed is critical. And in large-scale industrial settings, it helps reduce operational cost without losing too much performance. Now that we've covered business value, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which environment is especially suitable for distilled models? The correct answer is mobile and edge devices. Distilled models are ideal for mobile and edge environments because they require fewer computational resources. Question 2. What is one major practical advantage of a distilled model? The correct answer is faster inference. A distilled model is typically smaller and faster, which improves inference speed in production. Question 3. Compared with RAG, model distillation is mainly about. The correct answer is compressing model knowledge. RAG focuses on retrieval plus generation, while model distillation focuses on transferring knowledge into a smaller model. That's the essence of model distillation. If you are evaluating AI for business use, this is one of the most important ideas for balancing performance with cost and speed. Thanks for watching and keep learning step by step.